Hey everyone, welcome to this explainer. Today, we're tackling exactly what you need to know for the title topic, NCP-MCI 7.5, 6.10, Affinity and Anti-Affinity. As your guide, we're going to systematically master this subtopic so you can absolutely crush this section of the exam. Today is entirely focused on how Nutanix handles VM placement, which, as you know, is a really critical component of your certification journey. We're going to take this at a nice, steady teaching pace, making sure you don't just memorize the rules, but actually understand the underlying logic of why the system behaves the way it does.
So here's our exact roadmap for today. We'll cover 1. Why placement policies matter. 2. VM host affinity rules. 3. VM anti-affinity rules. 4. RBAC and PC management. 5. Those tricky common exam traps, and we'll wrap up with 6. The key facts you absolutely must memorize.
All right, let's dive right into Section 1. Why placement policies matter. The rules of VM placement.
Now, before we get too deep in the weeds, let's just make sure we're on the exact same page with the alphabet soup, so we have a rock-solid baseline. Obviously, you're managing a VM, or virtual machine, running on AHV, the Acropolis hypervisor. You're going to configure your larger category-based rules in PC, which is Prism Central, and that trickles down to the local cluster level managed by PE, Prism Element. Then we've got HA, High Availability, which is what rescues your VMs if a node fails, and ADS, Acropolis Dynamic Scheduling, which is constantly shuffling workloads in the background to balance resources. Finally, there's RBAC, Role-Based Access Control, which dictates who's actually allowed to set these rules. You really need to know exactly how these gears turn together, like how a rule in PC overrides a local PE configuration, or how AHV talks to ADS, if you want to score full points here.
Okay, here is the core juxtaposition you simply must understand. VM host affinity is a mandatory rule, while VM anti-affinity is strictly preferential. This honestly illustrates the entire philosophy of subtopic 6.10. When you tell a VM it has an affinity to a specific host, the system treats that as a strict, non-negotiable must. It will stubbornly refuse to violate that rule no matter what. But when you tell two VMs they have an anti-affinity to each other, meaning, you'd really prefer they don't share the same hardware, the system treats that as a should. It'll try its absolute best, but it's not going to break your environment or block your commands just to enforce it.
Moving right along to Section 2, VM host affinity rules, meaning mandatory VM placement.
Because VM host affinity is a strict rule, it actually puts a hard leash on high availability and Acropolis dynamic scheduling. It will flat out refuse to power on a VM on an unauthorized host. If you apply a VM host affinity policy, you're severely restricting that virtual machine. If an HA event happens, say a host just completely crashes, and the only available space in the cluster is on a host that isn't in your affinity policy, that VM will not power on. It is stranded by design. ADS is also going to completely ignore this VM when trying to load balance the cluster. And why? Well, because the system is built to prevent these endless futile loops where ADS tries to optimize performance by moving a VM, only to have the hypervisor immediately rejected due to the affinity rule. You can set these up at the VM level directly in Prism Element, or if you're dealing with large-scale environments, you'll use category-based policies in Prism Central.
Think about a real-world scenario for a second. Let's say you've got this clunky legacy application that absolutely must stay on specific hardware solely for licensing reasons. This right here is the classic concrete example for VM host affinity. You have a piece of software that licenses itself based on the physical CPU cores of the server it's running on. Just imagine the financial fallout if someone accidentally migrated an Oracle database to an unlicensed core. Yikes. This is exactly the disaster VM host affinity prevents. You're basically telling the cluster, look, I do not care if this host is overloaded or if it crashes, this VM must never ever run anywhere else. The system respects this mandatory requirement above literally all other performance optimizations.
Let's shift gears now to Section 3, VM anti-affinity rules, which handles preferential VM placement.
So this policy acts as a should rule. That means the system won't block your manual migrations or your maintenance tasks, and ADS just tries its best to fix any violations later. The overall goal here is super simple. Keep specified VMs apart so a single hardware failure doesn't take them all down at the exact same time. But because it's soft enforced, it's incredibly flexible. If you need to put a host into maintenance mode and manually migrate a VM onto a host that already contains its anti-affinity partner, the system's going to let you do it. It's not going to throw a big red error and stop you in your tracks. Once your maintenance is done and resources free up, ADS will step in on what they call a commercially reasonable effort basis. That just means it passively scans for opportunities to separate them again over time without disrupting your active cluster operations.
If you remember nothing else about Anti-Affinity, memorize this exact phrase. Powering on a virtual machine will always take priority over anti-affinity rules. The crucial takeaway here is that Nutanix prioritizes a functioning, running workload over ideal placement. If your cluster is super congested and the literal only way to power on a critical VM is to place it on the exact same host as its anti-affinity partner, the Acropolis hypervisor is going to power it on anyway. Uptime trumps preferential separation every single time.
A perfect example of this in the wild is protecting two database nodes. You obviously want them on separate hosts, so one hardware failure doesn't take down the entire database. You've got your primary database VM and your replica database VM. Under normal operations, ADS keeps them safely on separate nodes. But imagine a worst-case scenario. A massive cluster failure happens, multiple nodes go down in a split second, and you only have one surviving node with enough compute to run both. Because anti-affinity is just a preferential should rule, HA will successfully restart both database VMs on that single surviving node. It knows that having both nodes running on shared hardware is vastly superior to having one node powered off completely.
Moving on to Section 4, RBAC and PC management, meaning role-based access control and Prism Central.
To manage these rules in Prism Central, the exam is absolutely going to test if you know that you need view VM and view category as foundational permissions before you can assign any specific policy controls. This is a layered approach. An admin can't just be handed a create VM host affinity policy permission and expect it to magically work in a vacuum. Because these policies in Prism Central rely on assigning categories to VMs, the user's role absolutely must include the base permissions to actually view the VMs and view the categories first. Only then do the specific create, update, or delete policy permissions actually become functional.
So, if policies are set in Prism Central, they'll periodically reconcile and override any localized rules configured on Prism element. What's really interesting here is the hierarchy it establishes. If you have a cluster registered to a Prism Central instance, PC becomes the ultimate single source of truth. This is a massive architectural philosophy for Nutanix. When PC is in play, it dictates the law of the land, stopping rogue local configurations from breaking compliance. If a local admin logs directly into a Prism element cluster and tries to set a legacy affinity policy that conflicts with a PC category-based policy, Prism Central's reconciliation process will eventually sweep right through and enforce the PC policy, maintaining that global consistency.
All right, pay really close attention here. Section 5, Common Exam Traps. Do not get tricked on test day.
Here's a sneaky one. If a host fails and a pinned VM cannot migrate, you have to explicitly set the non-migratable VM action parameter to ACPI shutdown to power it down gracefully. Let's unpack this trap. You have a VM with a strict host affinity rule, and that host loses power. High availability kicks in but realizes it's completely forbidden from moving this VM to another host. The VM is now classified as non-migratable. By default, the system might just leave it in a suspended, undetermined state. Do not let the exam trick you into choosing power off or suspend here. The exact syntax you need to look for is ACPI shutdown, which tells the hypervisor to send a clean shutdown signal rather than just leaving the poor VM hanging. Now, this is an absolute classic trap. Cloning a VM drops the policies, but restoring from a disaster recovery snapshot preserves them automatically. The underlying why here makes perfect logical sense once you see it. When you clone a VM, you're creating a net new entity, usually for testing or spinning up a new service. It generally shouldn't be bound to the exact same strict hardware limitations as the original. But when you restore a VM from a DR snapshot, the goal is exact continuity of a failed workload, right? Therefore, AHV automatically reapplies the original affinity policies to ensure the recovered application remains perfectly compliant with your infrastructure rules.
And another huge gotcha, remember that UUIDs stick to the VM. If you migrate a VM to a new cluster without stripping the affinity rules first, it simply won't power on. This is perhaps the most common real-world mistake that ends up on the exam. A VM host affinity rule in Prism element is tied to the unique hardware UUID of that specific physical node. If you export or migrate that VM to a completely different Nutanix cluster, that physical node UUID doesn't exist there. The VM boots up, searches desperately for a host hardware ID that simply doesn't exist in the new cluster, and fails to start, throwing an error that can totally baffle unprepared admins. You've got to manually remove the affinity rule before migration.
Almost at the finish line. Section 6, Key Facts to Memorize. This is your final cheat sheet.
Seriously, commit these 4 points to memory, and you're going to easily navigate any tricky placement questions they throw at you. Let's recap them one last time. VM host is your rigid licensing enforcer. It's a must rule that will gladly leave a VM powered off to maintain compliance. VM is your flexible availability helper. It's a should rule that relies on ADS to do the heavy lifting later. Because of that, powering on a VM will always beat an anti-affinity preference. And finally, watch out for those operational traps. Clones drop their policies, while DR restores rigorously maintain them.
So as you hit the books and continue prepping, always ask yourself, can I clearly identify the mechanical boundaries between strict affinity and preferential anti-affinity? If a massive, multi-node failure hits your cluster tomorrow, are you 100% confident your policies will protect your workloads without accidentally violating your software licenses? Review your environment, master these rules, and you won't just crush the NCP-MCI 7.5 exam, you'll bulletproof your infrastructure. Thanks so much for joining this explainer, and I will see you in the next one.